I am Pakistani and you watching Mr. Pakistan at it. Today this video I will teach you how to can make a simple RPM meter using the Hall effect sensor and plus magnet. So showing this and the display, this is display first using arduino board. First, basically I made this video about 1 month ago. Get it out. Get the tab out. Basically I made this video about 1 month ago. Accidentally when I editing time I will upload and not upload it, instead it will delete out or lost them. So today I made this video again. So previous video, I mean this video below, then you can find a code from all effect sensor video. So I mismatched them. So right now it's time to test. Now this is Arduino which is powering power band. There are 16:2 display. This time you might see this jumper across my display. Because this jumper is display as a fault inside. So when I turn on after a few milliseconds it will turn off the backlight. So I bridge the backlight pin to the VSS pin. So it always turn on the backlight, so it no happen. Its backlight will not off and all the time. Because it's not go sleep mode. That is a fault. I fix it, but you cannot do this jumper for this project. So Arduino 5-volt ground spline, 5-volt ground to this display. This is I2C display using I2C backpack module, which 5-volt ground are connected to Arduino 5-volt ground, SDA to analog 5 or SDA, SCL to SCL. Now you start, and this is all. This is a all effect sensor, which sensor has 3 pins, digital sensors 3 pins, 5-volt ground and signal, 5-volt to 5-volt ground to ground of the Arduino, and signal pin is connected to the digital 2 pin of the Arduino, which is a digital pin. Right now keep away for magnet initialization. Now if I try to sorry please. The wires are loose. Once you start, maybe wires are not losing to magnet, which I already salvaged from microwave magnet. So there's a powerful magnet. You can use any small neodymium and tiny little magnet. So you bring the magnet close the sensor. Oops. It is attached. So you can see 60 RPM. Right now if I hold on the top table, now if see, so you can see in the screen, it's those, maybe this time it's not clear because I'm sitting outside. So that's why, so you can see, let me hold. So you can see when I close the setting of man close to the this sensor, you can see the reading is changed. It is depending how much I can fast set it. Like that. This time it will sometimes trigger, sometimes not trigger because due to magnetic polarity issue. Because I move this magnet balance pin, so polarity may be changed. So you can see it's to 60, 120. That way. So what you can do, you can take a small magnet, attach your motor, toss some propeller in the motor, which motor you then need to measure the speed, and run the motor with oil power. And when motor is rotating, magnet move faster. So it's count how many times magnet will attract and repel this sensor. It will count and display the total RPM, which is calculated by internal formula. Normally I will set in by my ads, so we can do maximum 180 somewhere in my ad. You can connect this is a very huge magnet. Bigger magnet, you can use tiny little magnet, attach motor or your bike wheel, and then this bike wheel chassis, you can attach the all effect sensor. When bike wheel spinning, it will pass the magnet back and forth. It is counted how many times magnet comes across this sensor and tells the arduino which 10 counts, which how many speed or how many time rotation or revolution per minute tire will spin, or your motor will spin, or your bicycle will spin, wheel will spin, and display into the 16 into 2 tractor display with eye to still see back part of this module. So there's a benefit of this backpack module is only just it is that 16 input output pins of the display using convert into 4 pin interface, meaning then use 4 pins only to communicate with this entire 32 digit display, which is a 16 into 2. 16 digits in one row, total 2 rows, which means 32 digits. And this way you can spin 12,000 RPM or even more them with this magnet and this skin. And this video is the next video. By the way, the video provided in the end of the video, now explained in the also in the laptop screen later. Those are the stored for this all effect sensor based tachometer 80 RPM meter. First, Ash includes wire.h library for serial communication. Ash includes liquid crystal.I2C.h library for liquid crystal I2C display. There will one more LC display.h library which is not used because this is stored for LCD without I2C, so I use I2C variant, so I block this. And here is liquid crystal LCD 16 into 2 20 0 to 27. Here is the resolution set of the display. Constant int all pin equals digital 2, meaning all sensor digital 2. Constant mil unsigned launch sample time equals 1000. 8-bit unsigned constant 8-bit launch sampling time is 1000. Constant int maximum speed 10 to 100. Wide setup all sensor. Pin mode all pin is input border 90606 for serial communication. LCD bit 16 LCD.bit 0 into 27 and 16 into 2 for LCD resolution. LCD print installation delay for 1 second or 1000 millisecond. LCD clear void loop delay again 1 second. Int RPM that RPM integer RPM equals that RPM. LCD clear display RPM display bar RPM display bar RPM int that RPM between that in RPM int T out equals 0. T out is very variable is 0. T flat low unsigned turn time equals 0. Unsigned launch start time in milliseconds. Turn the mills function here, while turn time equals sampling time. If digital read all pin I flag I. If digital read all pin low, T flag equals to I. T out plus T flag low. Turn time equals mills start time. Int count to RPM equals int 6000. Float sample times. Return T out to RPM. Wide display RPM in LCD clear LCD cursor 0. LCD print RPM DEC. LCD set cursor 7. LCD print RPM. Wide display bar RPM. Int num base map RPM 0 to max RPM 0 to 15. Without 15 set LCD cursor 1 RPM equals not greater than 0. Point there is a for loop. Int I is variable 0. I less greater than number of bars plus I plus LCD cursor I1 LCD wide 1023, which is the maximum resolution of the Arduino 10-bit resolution. And this video can be